Hello everyone, let's talk about another medium problem on Leetcode today. Sort colors, Leetcode 75. It is also called Dutch national flag problem. In this, we are given an array nums of n objects colored red, white, and blue, because those are the three colors in the Dutch national flag. We have to sort them in place so that objects of the same color are adjacent with the colors in the order red, white, and blue. Then we will use the integer 0, 1, 2 to represent the colors red, white, and blue respectively. You must solve this problem without using the library sort function. The example one is nums is 2, 0, 2, 1, 1, 0, and then all the zeros come in the start. So 0, 0, 0, 1, 1, and then 2, 2. So that is the output. Now that we have understood the problem, let's jump into the solution space. There are many solutions possible for this problem. One of the easiest ways, like we can actually use the bucket sort that we saw in relative sorts problem. So the idea is that we can actually create three variables or an integer array of three elements to count the values of 0, 1, and 2 in the array. So suppose in this array, we can see that 0 occurred 2 times, right? 1 occurred 2 times, and 2 occurred 2 times as well, right? Now the use of nums array is done, so we can modify it and we can do it in place. So we will first move all the two zeros together, then we will move two ones after that, and then we will move two twos after that. So this is also a perfectly acceptable solution. And in terms of time complexity, it will be O of n. And in terms of space complexity, it will be O of 3, which is equal to O of 1. But what we can also look at is something called quicksort partitioning, where we will have three partitions in the array such that all the smaller elements come to the left partition, all the largest element, in this case 2, will be on the right of the partition, and all the ones come in the middle. Let's see how. The idea of partitioning comes from Quicksort. In Quicksort, the idea was that we can define pivot element, and all the elements on the left of the pivot are less than p, and all the elements on the right of pivot are greater than p. And partitioning this array around the pivot just takes O of n time, or the linear time. And now let's see how we can actually apply this in sorting the three colors. So if you look at it, what element can actually be the pivot? And the answer will be the middle element, right? Because we want all the elements smaller than it on the left and all the elements greater than it on the right. So we can define three pointers, L, R, and M. So L is for all the elements which are less than 1, because 1 is our pivot point, marking the end of zone of zeros. R is the start of the zone of twos, and M is the pivot point that is currently being checked. Now that we have defined left, right, and middle, this is how our array will look. This is the right boundary, so we will have all the twos here. Similarly, we will have left boundary, which will have all the zeros. And this is somewhere here, maybe our middle pointer. And here there will be all the ones. And this is the unknown area for M, but this is all known area so far. So the way the algorithm will work will be simple. So initially both left and middle will point to the start of the array, and right will be pointing to the rightmost point. So when we are processing the middle element, the value can either be 0, it can be 1, or 2, right? Whenever the middle pointer value is 0, we actually move it to the left. So how we do that? We can actually swap the values between left and middle pointer. So suppose we got a 0 here, right? So we will actually move this 0 at the left boundary, and move or swap the value right of the left pointer to the position M. In that way, both left and middle pointer actually move to the right. But suppose if the value at M was equal to 1, in that case, we will just increment the pointer M, because 1 is already at the correct place. Now, suppose it was 2, then it becomes a bit interesting. And the reason is, like, right side of the array is still not processed. So suppose our R was here and there was some value, either it can be 0 or it can be 1, right? Or it can be 2. Suppose we swap 2 with 1, in that case, we don't have to worry about anything. But if it was 0, that means we have to still process that value, right? And move it to the left. So that's why we will not increment the M pointer, but we will only decrement the right pointer, and we will decrement because we are coming from right to left. And eventually when the middle pointer is actually more than right, that means left part was already sorted thanks to the middle pointer. Right part was already sorted thanks to the right pointer. And now we can actually stop the algorithm. So this was the basic idea. Now let's jump into the dry run part. So initially both L and M are at the start position, that is 0. and r is at the rightmost point, that is n minus 1, which is 5 in this case. So first value we check for am, which is equal to 2. So that means we have to swap it with the rightmost point. And notice that it is 0. So we get 0 here and 2 at the end. So 2 is now at the correct position. So we will decrement r. But because it's 0, so that means we have to still process it. So again, we see am is equal to 0. So that means our left and middle boundary both increment. So we will move both L and M to the right. So then again AM is equal to 0. So we will again move left and middle to the right. So now again AFM is equal to 2, right? But R is currently at 1. So now we will actually swap those values, right? And we get 1 here and 2 now this side. But now M is now pointing to 1 and R is decremented to the left. So R is now at position 3. Then we see A of M is 1. So in that case, we will just increment the M pointer. So now M moves here. We don't have to, because M was already at the correct position. That is 1. So now again M is equal to 1. So we will again increment M. Now M is actually more than R. We can actually stop the algorithm because left side is already processed, right side is already processed by R. And that's how this whole run is now coming to an end. And we can see that the array is actually now sorted. So we have 2 zeros, 2 ones, and 2 twos in the same order. Now let's jump into the code part. So we will define these 3 pointers. Then we will just run the loop. For us, it will be m less than equal to r. If the value is 0, then we will just swap it with the left pointer, right? We will define the swap function later on, and let's increment the value of L. Else, if nums m is equal to 2, we will swap the value here between m and r pointers. Then we will move m pointer to the right, and we will decrement r here, right? And at the end of the array, we will just increment the pointer of m. But remember, for the case when the value was 2, we will not increment the m pointer. So we will have to decrement it here. And now let's define the swap function. So it will be very simple function. So we will have nums int I, and int j. I and j should be less than equal to length of array. In our case, it is. So we will just define temp. And now we can set the value at pointer I and set nums j equal to nums I. Oh, sorry, temp. That's it. And let's now run this code. Awesome. Let's submit this code. Cool. In terms of time complexity, it is O of n, where n is the length of the array because we are processing the elements of the array in this loop in a linear time. And space complexity is O of 1 because we are modifying this array in place. I hope this video was useful to you. If it was, please like and subscribe. Have a nice time.